This meeting is being recorded.
Local and global problems, but use Pacific Northwest as an example because it is centered around these water and environmental resources. So we have snowpacks and glaciers. We obviously have access to ocean, estuaries, rainforests, and an urban system which has an increasing population. So we are always dedicated to figure out what are the accurate resources which can help maintain these sustainability in these systems. Right, so that was kind of an overview of the program. What we're going to do next is I'm going to map a bunch of courses on the water cycle over here. So this is a schematic, that it is a figure which shows the water cycle. So on the top left, you have water storage in form of ice and snow, and then that water stored water eventually, it makes it into through stream flow, through infiltration, through surface runoff, it eventually makes it into the ocean, as you can kind of see this over here. And then you have a bunch of processes which occur in the ocean, and then you have processes which occur between the ocean and the atmosphere, like evaporation, radiative exchange, transport. And the idea would be, how do we teach you everything about this, right? So physical hydrology, one of our core courses, hits on water storage in ice and snow and how does it come into the water system. Then we have data analysis courses, which looks at exhaustive time series analysis and spatial analysis of, well, if you have a bunch of data from ocean, or USGS gauge data, what are you going to be able to do with that data? What is the statistical confidence on the data analysis which you're doing? So you learn those things. Then we have courses to address what happens once your groundwater percolates, and once your water percolates into the soil and it starts moving in the system. That is groundwater flow for you. We have hydraulics of sediment transport, which goes into what phase the sediment is moving. Is it suspended in the water column, or is it more like a bed load? How is it changing the bed form evolution? How is it causing local erosion? We have fate and transport, where we look at solute concentration of contaminants in water column, and how does it degrade, how is the physics, chemistry, and biology controlled of various materials. It could be like arsenic. Then we have courses on water management, where you learn about how to design systems for stormwater, wastewater management. We also have courses focused on ocean, like coastal engineering, where you learn about shoreline erosion, beach protection, interaction of waves with structures, marine renewable energy, and all of that cool things. Okay, this is our faculty members. We have 10 faculty members right now, and they teach you all these courses which I just mentioned. I am on the bottom column, fourth from the left, and my picture is the latest picture you can get of mine. Okay. We have three possible programs which you can work on. They're on your x-axis is the transition from a research-oriented to a practice-oriented, and on your y-axis, if you would, is time frame required to complete some of these courses. So if you were choosing a more practice-oriented theme, which could be a focus of some of the folks which are joining in today, you can theoretically complete your professional master's in less than a year. But if you're working at the same time, or if you have additional responsibilities, you might like to take a little bit more than 2 years as well. Then we also have thesis master's program, which is obviously research oriented. And then we have PhD, which can take 4 or more than 4 years, right? So this is what are all the possible opportunities which we have. And I'm going to cater a little bit more to the professional masters, but once again, feel free to ask questions on whatever aspect you would like to ask. This is actually similar to what Mike was showing before his computer got disconnected. This is a program plan, but for hydrology and hydrodynamics stream. And there are a bunch of core courses. The core courses which are listed right over on this slide are actually, these courses will give you a complete idea of the field. So when you take these courses, even during your master's or professional master's, you are expected to develop a strong understanding of the fundamentals of the field, understand how to apply it, and then also learn about modern tools. In addition, we are further dividing our programs into electives in addition to the core courses, which are in 3 streams. It could be in hydrology, hydrodynamics, or fate and transport. Right, so that is what is listed in this slide over here, where you can see a bunch of courses on hydrology, and then in hydrodynamics and fate and transport. But these are all courses which we offer. In addition to this, anything which you see highlighted in yellow is something which is offered in other departments. University of Washington has multiple departments, and there are overlapping courses. There are attractive things in other departments as well, and we encourage students to be able to take those opportunities, right? So like Earth and Space Sciences, School of Environmental and Forest Sciences, Urban Planning and Development, Oceanography, Aerospace, all of these offer courses which you might also find attractive. So what we are providing over here to you, especially for people who want to work in the professional program over here, is a possibility to finish in less than a year. If you take your courses back to back, you can do so. It obviously caters to working professionals. And if you are working as well as taking classes, you might like to take more time. However, the way things are designed over here is you pay per credit, you pay for the number of credits you take. So it doesn't matter if you're trying to finish the course in a year or 3 years. So we give you that flexibility. It is flexible, it is student interest driven. And now in recent past, we have even organized the schedule so that you don't have to come to the university like every day. You can just come on Tuesday and Thursday and get all your classes done. So this gives you more time to be, if you have other interests or other things going on, right? An obvious question one might have is, what opportunities do you get once you finish, right? So there are consulting opportunities. There are a bunch of consulting firms which are listed over there. You can work for the state through King County, or you could be working in government organizations like Army Corps of Engineers, United States Geological Survey, or Department of Ecology. All of these, there are graduates from our department who have worked in some of these organizations. If you spend some time on the website, you will see people have testimonials as well as to what do you think about the program. Some of these folks say that we offer a wide variety of courses which are pertinent to water resources. So if you want to work on water resources, this could be a good place. It is relevant to the current issues which we face in water sector, which is also a good thing. And finally, we maintain a delicate balance between emphasizing the theory, but at the same time applying it to real world, which is what, as a consulting engineer, you might like something like that, right? With this, I'm actually now going to walk you through some of the courses which we do. This is similar to what Mike will do later as well. And we'll go a little bit fast because you already have some idea of what the department, what this program wants to portray, right? So we have open channel engineering, which is taught by Andy Jessup, which looks at flows in free surface flows in a variety of natural and man-made structures. It could be flow through streams and rivers. It could be tidal bores. It could be dams and spillways, or weirs. And then we also look at, like flood control because of dam construction, or how would fish passage change if you have constructed a dam. So it looks at problems like this. We have hydraulics of sediment transport. Alex Horner Devine teaches it. And this looks at phase in which sediment moves in the water column. It could be moving as a suspended sediment, or you could have a bed load. It then looks at how does channels evolve, bed forms evolve, how do you erode the banks of a river, how do you create scouring because of bridge construction, and it has a bunch of impacts as well. Groundwater hydrology is one of our core courses, and this hits on the idea as what happens when water basically percolates into the soil, and then how does it move? What kind of equations describe this mass balance of water, or their momentum, if you would? And then you develop multiple analytical solutions to interpret how water is moving as groundwater. Some of this might sound a little bit theoretical, but the entire framework of this course is actually set up in a very applied sense. You will use the concepts to apply it to a hydrogeologic site in Woburn, Massachusetts, which has some historical significance as well. One of the other core courses is physical hydrology, and physical hydrology actually hits on the idea of you need to understand everything about the water cycle. So it actually talks about global water cycle. It talks about snow and snow melt. It talks about infiltration into the water, into soil, and then atmospheric processes like evaporation and transpiration. and many other things which are listed right over there. That is a fundamental course, and here now we have a more applied course, which is hydraulic design for environmental engineers. That is, how are you going to design systems through which we are going to move stormwater or wastewater in urban systems like we have in the Pacific Northwest? How are we going to separate stormwater before it goes into riverine discharge or things like that, right? So that makes this course very attractive in a more applied sense. Waterways for coastal engineers then goes into coastal oceanography and also into engineering along the along the shoreline. This is a course which Jim Thompson and I teach, and we look at wave dynamics in very shallow waters, restoration of property along the beach, or how do you generate marine renewable energy using tides or waves, and questions of that form. I also do another course on numerical modeling of hydrodynamics, and I'm just going to play some cool movies for you over here, where you can see, we look at creating models to look at wave propagation in very shallow waters, or the upper movie is showing you tidal propagation in coastal waters and things like that. And you can take it anywhere. It is a very open-ended course, and the idea is to help people learn what modeling tools they want to use for their work or consultancy. Um, Rebecca Neumann also teaches fate and transport of chemicals in an environment. Mike is going to cover it in a little bit more detail than me, so I'm going to go past it really quickly. But the idea is to provide a fundamental knowledge of biophysical and chemical processes which govern the fate of chemicals in surface water and in groundwater, like arsenic, and how does it degrade as a function of time because of chemical processes in addition to the physical processes which are acting on it. Advanced hydrology taught by Erkan Istanbuloglu builds upon the physical hydrology course and is primarily on process-based and stochastic hydrological modeling. And this is a great course. This will help you learn a lot of tools which practitioners use, consultants use to do hydrological modeling for the state. So that makes it a very relevant course. If you start thinking about more in global scale, Faisal Hossain teaches satellite remote sensing for water resources, where you use basically satellite data to figure out in what form does water exist, and can remote sensing be used to get data at locations like where we are data starved, like in developing nations. Jessica Lundquist teaches snow hydrology, and the focus of snow hydrology is to understand the cycle of snow cap development and then melt seasonally, and how does it change the watershed system in the Pacific Northwest and elsewhere. Hydrodynamics is taught by Alex Horner-Devine, and this looks into analyzing fluid flow which is occurring in the environment. It could be at the mouth of the estuary, it could be vortex generation in middle of the ocean, or turbulence evolution in a rotating system, and many other similar principles. This is advanced surveying is the latest course which has been introduced by our newest faculty, David Sheen, and this also has a very practical implication, and it covers all modern surveying techniques for three-dimensional modeling, structures from motion, terrestrial laser scanning, and RTK GPS. And the courses are designed so that you have field outings, you do hands-on data collection, and then you process it and understand it. Okay. This is just a reminder that in addition to all these exceptional courses which we provide, we also provide courses from other departments like oceanography, urban planning and development, School of Earth and Forest Sciences, Environmental and Forest Sciences, and whatnot. Okay. In addition, we have other resources. We have a new NASA wave plume where we do wave, winds, and currents. It is a teaching flume as well. We have multiple research labs. If you spend some time on our website, you will see that. We have computer resources which students use, and seagoing resources if one of you would like to participate in an oceanographic cruise. This is some dates over here. Your application deadline is December 15th, 2018, and you will get admission notifications by March 15th. The website, which gives you more details about the hydrology and hydrodynamic program, is also listed over there. This would be a good transition point for going back to what Mike was talking about. So I'm going to stop sharing my screen and Mike will join in.
Yes. This is Mike Brett again. Sorry about getting disconnected last time. I don't know why that happened, but it did happen. And so I was in the middle of talking about our course plan for professional master students, and I'll just talk about this one. I won't go into all the different course plans, but this is fairly representative of what you would be doing. If you were doing a thesis track, then you would obviously substitute some credits from the thesis track for some coursework credits. Nirni already mentioned this, Professor Kumar already mentioned that we're trying to do some things to really improve the experience for the master students in our graduate program. And one of the big changes that we're implementing, and I think you would be the first class to see the full benefit of it, is to align our classes so that all of the class offerings a particular quarter are either being offered on Monday and Wednesday or Tuesday and Thursday. And that is very beneficial for many students because my experience is about probably more than half of the graduate students in our professional master's program also have jobs in some of the local firms. A lot of them have internships with local engineering firms. The job market in Seattle for environmental engineers is very good. And so a lot of students like to work part-time and get some experience in some of the local firms. And so we're making that change to our curriculum. The other thing that we've done recently is we've put the students in charge of our seminar series. We've had a seminar series in this department for a long time, and the students were very eager to have an opportunity to take that over. So the students get to invite the speakers, they get to have lunch with the speakers, they get to meet them, they get to have, obviously complete control over which topics are covered in our seminar series. So we think, we're doing those. We've got other plans in the works to really try to continually improve the program based on feedback we've been getting from students and exit surveys and focus groups we've been doing. So I feel really good about that. I'm going to spend some time talking about some of the classes that we have available for the environmental engineering track. We have this year, I think, 25 students in environmental engineering track. So it's very active graduate group in our department. It's one of the most active graduate groups. And the first class I'm going to talk about is actually a class that I teach. It's called Applied Limnology, and it's basically the geology, the physics, the chemistry, the biology, and the management of surface waters, with a heavy focus on applied problems, and the most common being eutrophication, cyanobacteria, hypoxia, and trying to fix those issues. The pictures here are Klamath Lake and Crater Lake, which are, interestingly enough, one of North America's most degraded lakes and one of North America's highest quality lakes. And they're about 20 miles apart, and the water from Crater Lake flows into Klamath Lake. So it's a very paradoxical situation to have basically almost the highest quality lake in North America connected to almost the lowest quality lake. And very interesting to consider why those two lakes are as different as they are. Another core class that we have is microbial process fundamentals, and that allows us to understand the mechanistic characteristics of bacteria that are very important in natural and in engineered systems. So one of the really most promising areas of environmental engineering is harnessing bacteria to do very important transformations. So if we want to remove a particular contaminant, one very effective way of removing specific contaminants is to create environments that are favorable for bacteria that have the capacity to degrade those. And so a lot of research is going into trying to figure out which environmental conditions are characteristic for the bacteria that we would like to have in our engineered systems. A really interesting one that I've already mentioned is the Anammox bacteria. It's a bacteria that has the capacity to combine nitrite with ammonium to create nitrogen gas. And so you can remove nitrogen using that pathway. And an advantage of using that pathway to remove inorganic nitrogen from waste streams is it requires much less energy than a conventional removal process because it's done at much lower levels of oxygen and much less intensive aeration. Another class that we have is biological treatment systems. And so that's basically applied version of microbial process fundamentals. It's the specifics of how you harness bacteria to treat wastewater. So how you use bacteria to remove organic matter, how you use bacteria to transform nitrogen in particular, also how you use bacteria to produce methane. One of the interesting things about wastewater treatment is if you have a sufficiently large plant and you design your sludge digester appropriately, you can use the methane produced by the sludge digester to fuel all the energy needs of the plant. And so all of that's based on knowing how to harness the biochemical properties of different types of bacteria. Another class that we have is aquatic chemistry. It's one of our core classes, kind of a really foundational class, and I think it's one of the more challenging classes in the department, but students also come out of it saying that it's one of the classes that benefited the most in their career. And so this is going to give you a very strong overview of all the physical, chemical processes that you'll be using in professional practice. We also have a second permutation of that class, another level of detail, physical chemical treatment processes. So this is how you would design systems to utilize things like coagulation, flocculation to remove particulates from water. Another area that gets covered pretty intensely in an area of specialization for the instructor for this class, Professor Korshin, is corrosion reactions. So you've probably all heard about the incidents of drinking water degradation due to corrosion in the distribution systems in Washington, D.C., and then more recently in Flint. And so this kind of reactions are very important in environmental engineering, and Professor Korshin is an international authority on that and covers that topic pretty extensively in his classes. Another area that we have very strong faculty is environmental organic chemistry. That's Professor Michael Dodd. He's a world authority on oxidation reduction reactions and disinfection processes. And so he's very, very knowledgeable in that area and offers some fantastic classes. Another class taught by me is lake and watershed management. So this is the specific engineering approaches that we can use to restore systems that are severely degraded. There's common approaches that are used, most common of which would be alum treatment. A lot of lakes get treated with alum, so we talk about stuff like that. Another thing that we've been doing a lot in the class is trying to figure out how to best apply environmental models. Professor Nerney talked about modeling, and we have several faculty in both our hydrology and our environmental engineering groups that use modeling. So in my classes, we talk a lot about environmental modeling and best professional practices for modeling, how to assess whether models are working or not. One thing that I would like to kind of throw out there is that we're talking about it from the perspective of the hydrology and hydrodynamics group and the environmental group, but I like to think of us having a tremendous amount of overlap. We both are kind of laying claim to Professor Newman as members of our group. She's kind of in the middle, but one area of research that really combines the elements of both groups, it's very, very important for Seattle, is dealing with combined sewer overflows is a huge area of research and investment in the Pacific Northwest. I think Portland recently spent about $1 billion dealing with combined sewer overflows. In Seattle, King County and City of Seattle are currently spending $1.5 billion in dealing with CSOs. So that creates a lot of job opportunities, and those jobs are right in between the two fields of hydrodynamics and environmental, because you're both trying to control the flow of water, but you're also trying to remove constituents from the water. And so there's a lot of job opportunities. I think we have great course opportunities available for students that would want to pursue that. And there's a lot of engineering firms in this region working on those kind of projects. Another area that we have is advanced topics. And so there's some very interesting stuff going on in environmental engineering these days with, membranes, other advanced processes to treat wastewater. We've got right now in King County arguably one of the most modern wastewater treatment plants in the entire world called Brightwater. It's almost entirely a membrane system. Very interesting, applications going on that plant. Very state-of-the-art issues with odor control. That plant's built in a fairly residential area, and they invested a lot in odor control and in some very interesting geotech stuff going on with that plant. They built a tunnel that was about 300 feet underneath the ground that connects it up with Puget Sound about 10 miles away. So there's very, interesting stuff in that area. This is Professor Rebecca Newman's class again, and she does fate and transport. And her area is especially redox reactions and how those vary in the subsurface. Her area of expertise is arsenic transport in subsurface systems. The classic case study that she did her PhD and a lot of her research even today is the groundwater contamination with arsenic in Bangladesh. And that really has to do with oxygen availability, and that's determined by whether the bacteria in the subsurface system get enough organic matter to consume all the oxygen. And if they do consume all the oxygen, it changes the redox state of the arsenic, and the solubility of the arsenic in the water is entirely dependent upon its redox state. In some redox states, it's highly soluble, in others, it is not. So when the water is anoxic, the arsenic can move around freely. One of the interesting things that I've learned from her research is that Bangladesh has some of the biggest problems in the world with arsenic in the groundwater, but there's actually no more arsenic in the subsurface matrix of Bangladesh than there is other places. It's just the conditions in Bangladesh are very favorable for that arsenic to be in its reduced and mobile form. So she's doing some fascinating research and has some very interesting course opportunities. I think we have, very strong course opportunities related to biogeochemistry being offered by a number of faculty, both in our department and other departments at the University of Washington. It's very, very strong as far as that goes. We have, as I mentioned before, 2 professors that do air quality related research. And so Tim Larson teaches some 400 level classes and some 500 level classes in modeling the fate and transport of air pollutants. So those are very strong and well subscribed student classes in our department. Professor Korshin also teaches water quality modeling and management. So I teach a modeling class sometimes in kind of best professional practices. Professor Korshin teaches a class in kind of how you set up these models and how you run these models. And then Professor Newman also teaches a class in how you do fate and transport models for subsystems. The hydrology group offers several modeling classes. So I think we have a really good suite of modeling classes, which if you get out into the consulting world, you're going to spend a lot of time working using those type of platforms. And so those are the classes that I want to talk about. I think, Professor Kumar did a fantastic job of giving you kind of overview of the departments and kind of some of the logistical issues you need to pay attention to get yourself lined up for admission to this department. I think we have a really complementary, course offerings between the 2 groups, and we have very strong course offerings available across the department, across the university. There's a very large and a very strong and College of the Environment at the campus that has many complementary courses. And we oftentimes recommend that students take several classes, from departments outside of ours. That's what I think I need to talk about right now. And I think what we want to do now is to give you an opportunity to start to ask us a few questions.
So any questions you have, just please put them in the chat and we will try to get to as many as we can. One question asks, if my school doesn't offer fluid mechanics for undergraduates, is it possible to take the course during the first term?
I can answer that. So yes, actually what happens is You can take, we teach, in addition to the courses which are mentioned today, we actually also teach an undergraduate fluid mechanics class, which is a 300 level class. And I teach that, and a bunch of other faculty members teach that over here as well. And I have had multiple graduate students sit in the class, like audit it. And you can also take it as you can also register for the course. And it gives you the fundamentals of fluid mechanics, which you need for civil engineering. So it sets you up very well for the other courses which you will take on a graduate level.
And right now that class is being offered twice a year, but soon it's likely to be offered 3 times a year.
It will be. So for now it is twice, so it happens in fall and winter. But with the incoming environmental engineering program for bachelors, we might even offer it 3 times. So fall, winter, and spring. Yeah,
so Professor Kumar just mentioned we have a fairly rapidly growing undergraduate degree in environmental engineering, as well as an undergraduate degree in civil. The classic degree in our department has been civil, but our number of students that are taking environmental is increasing fairly rapidly.
And 15th December is the final deadline.
Yes,
right,
yes, December 15th, final deadline. If you have questions about GRE scores, just email CEG info. That seems to be the typical. There's a little bit of leeway, but usually we start reviewing applications a week or 2 after. So that deadline is pretty strict. There's a question here about environmental and H&H, different masters that kind of share the same courses. Can you elaborate a little more, just where the differences lie and where there's overlap perhaps?
Yeah, well, I'll jump in and I'll say that, there are a lot of students that are kind of interested in environmental quality and natural systems. They kind of fall in between. And even in engineered systems, like I mentioned, CSO. So we've presented 2 different groups, but we recognize that there's a substantial number of students that kind of find themselves right in between the middle of them. And I think our curricula are flexible enough that we can mesh students up very well with their true interests. And so I'm advising several students right now that are taking half their classes in the hydrology and hydrodynamics group, because they really are interested in having professional opportunities, like working on something like combined sewer overflows. Because if you're doing combined sewer overflows, you have to know how the water is moving through the distribution system, but you also have to understand the chemistry and biology of the constituents in the water. So I think we're very flexible in being able to work with students that find themselves kind of like right in that area. And I think there's the 2 groups we really aren't 2 groups, we're really one group. We work together and we administer pretty much everything we do as one group, really. But we offer 2 different professional master's tracks.
There's a couple questions that are partially related. One is, do you know what the percentage of accepted applicants for the research track versus professional track tend to be? And then for those on the research track, what the interview process looks like at UW?
Okay.
Well, why don't I give you a little bit, and then Mike can add as well. So overall, I guess any given year, we probably get about 20 to 25 people who go into the professionals track. And then people who go into master's thesis and or PhD would be about 5 to 10. So that's typical. Over the time, you might think there are more PhD students because PhD is a 5-year thing, right? So that is kind of the distribution. When we invite people, we actually invite people who are applying for the professional master's program, as well as people who are interested in the research track. And the interview process is actually, it has a structure. So you're given an overview of all the courses and all the facilities which are over here. And then the professional master students are given a more extensive idea of what kind of stream they might like and what kind of opportunities they will get after that. While the research track folks then get to do a one-on-one interview with multiple faculty members. You get 30 minutes and you talk to them about your research, their research, try to find a good match, and that is how it goes on. And then we have like a dinner thing where everyone sits and talks about things.
Yeah, so what I would say about the funded versus the professional master's program is that there are a lot more people interested in having a funded graduate project than there is funding available. So there's, finite amount of funding, and there's a lot of people that would like to do that track. And so it's obviously harder to get into a funded project. The key thing I would say with the funded project is, for that to work out, it's very important that the interests of the prospective student and the leader of the project, which would be one of the faculty in this department, line up really closely. So faculty are really looking at students that have interests and expertise that matches the project very well. That's very important, because research is very challenging. One of the things with research is that it's really not worth doing unless it's something that we don't already know the answer to. If we know the answer to, there's really no point in doing it. And if we don't know the answer to it, it means there's oftentimes going to be a lot of setbacks. And so the only way that you can be really a successful researcher is if you really enjoy the process of doing research. So we really work hard to try to mesh people up with the right projects so that they're very enthusiastic about the research they're doing. And we do have visitations. We invite quite a number of students to come in for visitation. We invite students from both tracks. And these visitations are an opportunity for us to get to know people better and to really find out who matches up the best with particular projects. Another thing that does happen a fair bit in this department is that projects, by definition, are not getting funded at exactly the same time that students are starting. So it's quite common for somebody in this department to get a funding notice for a project, and then to ask themselves, well, who would be a good person to work on it? And one obvious place we look for students is people that we already have in our graduate classes. And if there's a really strong student that's one of our graduate classes who is on the professional master's track, but they look like they really have the right background to do well on that project, then many faculty will recruit straight out of their classes. That's not to say that every professional master's student that comes to our department will be offered funding. Some will, probably, to be honest, less than 20%, but we do pick students. And sometimes what happens when people go to graduate school, they're not even quite sure for themselves whether a funded project or a coursework-based project is really right for them, because you don't quite know what research really is until you get in the middle of doing it. And so it gives us an opportunity to get to know people better. It gives them an opportunity to know the program better and to really figure out, like, which projects would they be interested in, who would they like to work with. And so I'd say it's somewhat fluid, with the caveat that we have a lot more people interested in funded projects than we have funding opportunities.
Okay, so let me try and answer this. Can students pursuing a non-thesis master's degree still do research with professors? Yes, there might be opportunities to do while you're doing your non-thesis master's degree and you want to finish it as a non-thesis master's degree, you can do small research projects with professors. If you would like to take on a full responsibility of research, it would probably make sense to go for a master's with thesis program. And for RA and DA positions, actually often for teaching positions, we do try find people from the non-thesis master's stream as well. However, things have started to change a little bit in recent past, and we probably don't offer a full teaching position if the person is from a non-thesis master's degree. It is more like an hourly position, which is at the same rate as a teaching position. But I think Eric can probably clarify that detail better than me. If you were a graduate student who is in the master's with thesis or PhD, there are three ways of funding it. Either there are students who have their own fellowship. It could be National Science Foundation based graduate research fellowship or NDSEG fellowship or one of other prestigious fellowships, or they could be funded by the faculty member who they are working with. That could be, they have their own, the faculty member has a fund and they put the students on a research assistantship. Or you could be teaching course, you can be a normal TA and that funds you. In general, you'll often see a PhD student or a master's with thesis students probably does a mix and match of this. For some time they will be on RA, and then on some, like once in a year, they might be teaching. And we offer actually a bunch of courses which requires TAs. So that is one way of funding it. I can actually, I just did.
How does it work for PhD and graduate students?
Well, I mean, you want to
Okay.
add to it?
So I can talk about the funding, just how it works for if you do get on a funded project, it doesn't matter whether it's a funded master or PhD project. The only difference there is the amount of time. But if you are on a funded project, then it does cover all your tuition cost. It provides a stipend. It provides money for insurance. So it covers all of that. It's pretty good. The students have some concerns about, the cost of living in Seattle, but I think it covers the minimum. It covers the basic costs.
To go along with the questions about funding, there's a question here about reaching out to instructors and faculty regarding their research and talking to them before submitting their application. Do you want to talk a little bit about how you'd recommend doing that, or if that's encouraged?
So in terms of getting to know the faculty and department, the best place to start is with our websites and to look and see what kind of research individuals do, and then to contact us. And we strongly encourage you to contact us. So we'll tell you that right now is the end of the quarter for us, so things are very busy right now. We're getting ready for final exams, or we're getting ready to submit our grades. So things are pretty intense. We have to all write a bunch of letters of recommendations for our students going to other universities. So sometimes maybe it takes 2 or 3 emails to get through to us. So don't be discouraged if you send an email to a faculty and they don't respond within 15 minutes. They may be in the middle of something, that day. So try a couple times to get in contact with them and just, find out about their interests, talk to them about whether they have projects that are coming along that they would need students for, and, get to know them is the best way. And then later on, we will have a visitation session. We won't invite every person who's applied to our department, but we'll invite, quite a few. And that'll also be an opportunity for you to meet with us face to face and get to know us better. And also to get to know the culture of the department. I think that's a very important thing, is just knowing whether this department's culture is a place that would really work well for you. I feel like it's a very positive culture, but you get a better perspective of that when you visit yourself.
Eric, can you answer that question? If you take a combined 400
Perfect. Yeah, I was so if you take a 400 or 500 level course, I think the question is really asking, do you have to repeat similar courses if it's part of the instruction? The answer is typically no, depending on what your faculty advisor is. We'll look over your syllabus, see if it meets that criteria. The thing to be aware of is if you want those credits to count, they could not have counted towards your undergraduate degree. So they have to do in excess of whatever you needed for your previous degree. It can't apply to anything else. And that's something you can work with the advising team on figuring out. There's another quick question about prerequisites. For the majority of them, you need to take them ahead of time. If there's something you're really concerned about, please email ceginfo@uw.edu. That's where we can answer some more of those questions. But yes, it's expected that those are there so you're prepared for the coursework, and that's why we want you to take them.
So I will answer the question, is it possible to pursue a research-based master's in the hydrology program? So to be honest, research-based master's in hydrology program is not common. There are people who do this, but in general, what happens is people start a PhD program and get a master's on the way. So at the end of their 2 years, they write up a dissertation and submit it, and that becomes their master's thesis, and they continue. However, that doesn't necessarily mean that you cannot do master's with thesis. I would suggest you to talk to the person you're interested in working with and see if this would be something they would be happy to pursue with you, and then go with that. So I think if you're interested in doing masters with thesis, talk to the faculty member and apply for it. There's no reason why you should not.
Yeah. So sometimes it works out just fine, because sometimes the faculty maybe only has funding for a 2-year project, and so you're not going to put a PhD student who's probably going to take 4 or 5 years to finish on a 2-year project. Sometimes it works out just right. But, as you've already heard, and there's truth to it, is that most people that want to have students on funded projects are preferring PhD students because from especially our perspective, when you invest a lot of time up front in training somebody, it's much more beneficial in the long run if you have a longer professional relationship with this person that you've trained. If you train somebody up for a master's, you spend 18 months training them, maybe 6 months, they're really, really productive, and then they take off. But if you train a PhD student, you spend 18 months training them, and then you have, after that, you have 2.5 years to work with them, if not more. So there is a strong preference for people that are interested in the PhD track for the funded projects.
There's a question here about international students in these two tracks. The only special requirement that I'm aware of has to do with your English placement, which is all outlined on our website. If you have specific questions about that, it usually is just either a degree from a English university in the United States or a TOEFL score, but there are a couple ways you can meet that requirement. So if you have questions, again, CEG info, and I'm happy to work with you on that. Do you have a sense of how many international students there are kind of between the two programs? Or
I would say international students in environmental is maybe a third of our master's students. Maybe
and it's the same. It's the same in hydrology. About 1/3 of students are international. Yes, but maybe less in the professional master's program, though. Maybe 1/4 or less in professional masters.
There's a question here about what the common balance between credit load and working hours for students kind of working at the same time. Do you want to talk about that? I can talk
about it. Well, so like I said, there's a lot of students that are in our professional master's program who are working at the same time. And, I have this conversation with many students. And what I always tell them is that the whole point of graduate school is to get as much as you can out of every class. You're not just here to grind out credits and get a degree. You're here to learn as much as you can. It's an opportunity for enrichment. And so I very strongly encourage the students that are working part-time to carefully balance their course load with their work commitment. And as Professor Kumar already mentioned, you're paying by the credit. And so there's no need to cram in a whole bunch of credits in a particular quarter. If you're working 20 hours a week, you probably should be taking 10 credits, no more. Really, balance things out carefully. There's no advantage in kind of stretching yourself too thin. You'll be frustrated at your part-time job, and you'll be frustrated in the graduate programs because you'll feel like that you're having a hard time keeping up. So we strongly encourage people to come up with a proper balance. And I think that's a very important role of your graduate advisor to give you that kind of professional advice, which classes you should be taking when, and how to kind of manage it all. If you're in a funded project, then there is an agreement with the union, the graduate student union, about technically how many hours you're working towards the project and how many hours you're working towards your own research, how many hours you're working on classes. That's all laid out by the union. Although, in the ideal world, students are so interested in their research that they're not looking at the clock when they're doing research. They're just, fascinated by what they're working on. That's the real place you want to be when you're doing research. Right.
I'm going to answer this question by Supriya Savalkar. So you have a master's in environmental engineering and work experience in flood modeling, and you want to pursue a PhD. So that is an interesting question, right? So in general, you pursue PhD in the field which you want to work on. So in this case, if you want to do flood modeling, I would suggest applying to the hydrology and hydrodynamics program, because that is where people who do flood modeling are. Arkan Istan Bulugulu, Alex Honor Devine, Jessica Lundquist, and even myself do a little bit of flood modeling. And we just had a big project start, which is an NSF funded project, which is looking at flood modeling in the Pacific Northwest. So actually, if you send one of us an email, we'll be happy to talk to you a little bit more about that.
Yeah, and I think there's also a very interesting connection to biogeochemistry here, because when you do have flooding of the adjacent river channel and the watershed, there's very interesting reactions that occur, maybe methane production. And I think we have several faculty in this department and in this university that are very interested in those type of phenomena. David Buttman, I'm interested in the kind of biogeochemistry that'll occur. This is the same kind of stuff that Professor Rebecca Newman's working on.
Right,
the phenomena that she deals with arsenic mobilization is directly tied to seasonal flooding.
So there's one last question at the end. Yeah, we're about out of time, but hopefully if we didn't get your questions answered, we at least
answered it. So the last question I see here is, can you comment on the frequency and success coming into this program with a science background, but not engineering? What are some of the things you suggest these types of students to do? So I would say in our environmental engineering program, I would say half the students are coming from science backgrounds. So we have students coming from very diverse backgrounds: geology, chemistry, environmental science. Every once in a while, even students coming from humanities,
Exactly.
And sometimes they you'd be the most surprised. I had a couple of years ago a student that was coming from the humanities that got absolutely the highest grade in my class, and now she has a very high-ranking job in King County Solid Waste Division. So she made the transformation to engineering very successfully. I find the students come from science backgrounds do very well in our program. The only caveat I would say is that sometimes they might want to brush up a little bit on maybe some of their quantitative skills, because pretty much everything that you're going to do in this department is going to take you in a quantitative direction. Maybe if you're coming into environmental engineering, you could brush up on chemistry if you haven't done some pretty rigorous chemistry recently. And we have opportunities to do some of those classes in our own department. Another thing that's important if you're coming from a straight science background is to learn the fundamentals of mass balance. That's really core to any environmental engineering, and core to hydraulics and hydrology. Is mass balance is kind of the backbone of it all. Those are things that you can pick up. You could, like we were asked about fluids before, there are classes you can take even within our department that would help prepare you to get off to a really strong start if you feel like some aspects of your background don't match up perfectly with the kind of classes that people would have taken if they majored in environmental engineering or civil engineering. But the short answer is I think the people with science backgrounds do very well in our department, and there's a lot of them.
I'm going to answer this. If you're applying for a master's thesis but interested in potentially continuing, I would suggest let them know as soon as you are sure about doing this, because sometimes, to be able to get a project funded, it takes time. It could take up to a year or more. And to ensure that you have funding to continue that work or similar work, it is better that the faculty member or related faculty members know that as well.
The other thing I would say too is if you get into our graduate program and you really feel like you want to do a PhD, faculty in the department can help you apply for national fellowships. And it is something that takes a while to get those together and to get them funded, but that's something we can help you out with if it really looks like this is the right place for you to do a PhD.
Right.
We can put together a team and help you get the resources you're going to need to have a successful PhD project.
On that note, if you're interested in applying at UW and work with someone over here, there's no reason why you cannot apply for fellowships now. You can apply even in the final year as an undergraduate. And one of us can help you a little bit with those applications as well, if that would be the faculty you want to work with. There was another question, is if it is recommended to contact individual professors regarding PhD research. I would say yes. If there's a certain faculty member you want to work with, it makes a lot of sense to not only contact them, but maybe even set up a Skype session with them. You should obviously mention them in the statement of purpose, but it would make sense to do one-on-one interaction if possible. And if accepted, there are multiple ways the PhD funding works depending on your credentials. There's a possibility that the department provides up to a year of fellowship for some students, and then you could either transition to a RA position with the faculty member, or you could be teaching.
I think that's most of the questions. And you've touched on a lot of these already.
Yeah, very good question.
Yeah. As more questions come up, again, please don't hesitate to email the general advising email. That's ceginfo@uw.edu. And if there's a process question that you have, that's a really good place for us to answer it. But if there's also content-related questions, we can direct that to the appropriate faculty who might know well.
Great. Yes.
Yeah, thank you for listening.
Thank you.
I really appreciate it.
Apologies for the tech challenges, but thanks for sticking with us, and have a good rest of the evening.